this video is going to focus on trigonometric identities. And basically what an identity is something that is always true. And in order to prove trig identities, we need to have these two little bits of knowledge pinned down in our brain. Okay, they don't come to us on any formula sheet or anything like that. These are fundamental identities, things that are always true about trigonometry. So the one is that tan theta can be written as sine theta over cos theta, and the other one is that sine squared theta plus cos squared theta is equal to 1. And if you're interested in knowing how to prove these, then you can actually do that by saying, well, I know that tan is y over x, and sine is y over r, and cos is x over r. And if you start to work this out, you'll see that you end up, once you've tipped and times and all the things, you end up with y over x. So these are definitely things that you can prove if you're interested in doing so. Something that is important to note is that the second one can come at us in different ways. So we can definitely have the sine squared theta plus cos squared theta equals 1 option. But sometimes we take one of these ratios over. And so then we would say, okay, well then sine squared theta, if we take cos over, is 1 minus cos squared theta. Or if we take the sine over, then cos squared theta is equal to 1 minus sine squared theta. Okay, so 3 different versions of the same fundamental identity. All right, and whenever you get tasked with proving an identity, I want you to remember you want to change all tans to sines over cos, and you want to keep a BDI out for sine squareds and cos squareds because they also provide you with a lot of options. Now, when it comes to proving identities, it's very important that you do this in a mathematically sound way. Okay, so there are 2 clues or clue words that I look for. Either show that or prove. If the question says either one of those things to me, then I know I need to use the special identity proving method. Okay, and I need to do that by separating the left-hand side and right-hand side. Okay, so you'll never solve this as an equation. You'll take the left-hand side and you'll work on it, and then you'll want to prove that it equals to the right-hand side. Okay, the next thing we want to do is we want to choose the more complex side. Okay, now in everything in life, it's best to go with what is simple, but when it comes to trig identities, you need to have options, and the complex side is going to give you options. And once you've done that, you want to simplify until you can prove that it equals the other side. Okay, so the most important thing here is really to do them separately. Let's look at some examples and you'll see exactly what I'm talking about. Show that. So there's my magic keyword, show. Okay, sine squared theta is equal to tan squared theta times cos squared theta. Okay, so I've got 2 sides here, a left-hand side and a right-hand side. And one of these is more complicated than the other, or complex. Okay, this one has got a tan, which can change into sine over cos. And this right-hand side has got 2 trig ratios, whereas the left-hand side only has 1. So that would definitely be my leaning, is to say, okay, well, let's work with the right-hand side. So the right-hand side is equal to tan squared theta times cos squared theta. Okay, tan, we know from our fundamental identities, is equal to sine squared, or sine over cos. In this case, because it's tan squared, they'll both be squared. And then multiplied by, and I always like to, the minute something is a fraction, I like to then just say, well, let's write that as cos squared over 1, because it helps us to see. Okay, now we're dealing with fractions. And because there's only 1 term on the numerator and 1 term in the denominator, same story here, I am allowed to cancel. So cos and cos, that can cancel. And so then essentially I'm left with sine squared over 1, which does just equal to sine squared theta. Okay, and then we go back and we have a look and we say, ah, well, that was the left-hand side. So we have then proven that this identity is true. All right, and I love to, at the end, you don't have to do this, but I then love to say, well, therefore, sine squared theta is equal to tan squared theta times cos squared theta, because we have proven it. Okay, I find this to be a very fulfilling section of the trig syllabus because I know for sure, because I've managed to prove it, that I'm going to get full marks for this question. So that's always nice to know. Here's another example. Sine cubed x plus sine x cos squared x over cos x is equal to tan x. So I'm looking for the side that gives me more options, and I think that is definitely here, this left-hand side. All right, so the fact that they've said to me prove means that I'm solving an identity, and I need to be careful about how I do that. I'm going to take the left-hand side, LHS, is equal to sine cubed x plus sine x cos squared x over cos x. Okay, be careful. There is this plus sign here in the numerator, which means that I am most certainly not allowed to cancel one of those causes. Okay, if there are pluses and minuses in the numerator or denominator, I have to factorize before I'm allowed to cancel anything. Right, so let's do that factorizing thing. What I can see is that there's a sign here in this term and there's a sign here in that term. Okay, this one is cubed, so I'm only going to take one of them out, but that's at least helpful. So let's take out a sine x, which leaves us then with sine squared x plus cos squared x, and then that is over cos x. Okay, now from my fundamental identities, I know that sine squared x plus cos squared x is equal to 1. So this then is going to be sine x times 1 over cos x. Okay, and now I might feel like I'm out of options, so let's just quickly regroup. What's our goal? Our goal is to end up with tan x. And what do we know? Tan x is sine over cos, or sine x over cos x. So then this is equal to tan x, which is equal to the right-hand side. And so therefore, that whole fraction is equal to tan x. Right, prove the following identity. I mean, there we go. This is as clear as can be. So left-hand side is this whole thing. 1 over cos minus tan squared cos squared minus cos squared equals, right-hand side is just a little tan squared. So let's take the left-hand side and pop that down. That's what we're going to work with. So 1 over cos squared theta minus tan squared theta, cos squared theta minus cos squared theta. Okay. Now, what I want to do is I want to change this tan, because that's one of my fundamental identities. I want to write that as sine over cos. Okay. Also, something worth noting, because I've noticed a lot of students do funny things here. We've got terms that are separated by pluses and minuses. So don't start putting funny brackets in weird places. Because these are multiplying, we have to treat this as one term. And so we need to simplify that. BODMAS says, let's write that down actually. BODMAS, it's been a long time since we've seen that. But BODMAS says we need to multiply before we add and subtract. So don't do these minuses. We want to times first. Okay, so let's do that. We're going to have 1 over cos squared theta minus, we're going to change this, sine squared over cos squared. And then I like to, as I said in the previous example, because I'm dealing now with a fraction, let's write that as a fraction too. That's going to help me. Okay, cos squared theta over 1. All right, so now this part that's multiplying here in the middle, this term, one whole term, I can simplify. I can say, well, that and that can cancel. All right, because there's just one term in the numerator and one term in the denominator of each of these fractions. Okay, so that leaves us now 1 over cos squared theta minus sine squared theta over 1 minus cos squared theta over 1. Okay, now you've got a couple of options here, but the fact that you're seeing so many sine squareds and cos squareds should make you think of that other fundamental identity. Okay, I think what most students would do, and so that's the method that I'm going to use, is get a common denominator here. Okay, there is another way to do it where you just take out a common minus, but let's do the common denominator because I think that's what's going to make more sense to you. Okay, so this one already has a cos squared, so let's use that as our common denominator. So cos squared times cos squared. And the rule of denominators is what I do to the bottom, I need to then do to the numerator also. Okay, so we want to write this whole thing over the same denominator, cos squared theta. 1 is okay, that can stay, minus, this is going to be sine squared theta times cos squared theta. And this is going to be cos squared theta times cos squared theta, or cos 4 theta. Okay, I've written it like that because I want you to spot some common factors that you could take out there. Okay, now at this point, I've got an option. I can sub this out and say, well, sine squared theta plus cos squared theta will equal 1, and we can go from there. But what I think to do now, and remember, this is the great thing about maths, is you can try something, you can come back, you can adapt your approach, try something else. But what I think would help us is if we took out a cos squared from each of these second terms, okay, or second and third term. So 1 minus, let's take out a cos squared theta. Okay, essentially what I'm doing is I'm taking out a minus cos. I hope I'm getting you thinking here with this example. That means I'm left with a positive sine squared theta in the bracket, and I'm going to have to change this here also to a positive, because a minus times a plus will give me that minus cos squared theta. Okay, so I didn't write this as cos to the 4, just so that I could make it easy for you to see we've got like terms here, or like a common factor. But if you wrote it as to the 4, that's okay. You'll still end up with the cos squared over there. Okay, over cos squared theta. And now this is looking very promising because we know that sine squared plus cos squared is equal to 1. So this then becomes 1 minus cos squared theta times 1, which is really just cos squared theta, over cos squared theta. Okay, not allowed to cancel because of this minus, but 1 minus cos squared theta is also one of those identities. Okay, so if we have a look at the fact that sine squared theta plus cos squared theta equals 1, then the fact that I've got 1 minus cos here means the cos went over and the sine stayed behind. So sine squared theta is equal to 1 minus cos squared theta. Okay, so that means I can then rewrite that numerator as sine squared theta. And then that goes over cos squared theta, and sine over cos is equal to tan squared theta, which equals the right-hand side. Okay, just to show you what would have happened if you had used another method here in this step. Okay, so once we had simplified, we would have taken from this step here 1 over cos squared theta. Okay, then from this step here, because these cos's cancelled, we would have just had minus sine squared theta, and then minus the cos squared theta that was originally there. Okay, and then what you could do is you could look at this and say, this looks so similar, except that my identity says plus and these say minus. So if ever the signs are not working out for you, you can factorize just to change the signs. So 1 over cos squared theta minus, we're literally just going to take out a minus 1, or just a minus, and then this becomes sine squared plus cos squared. And so that, we know, is just equal to 1. So this becomes 1 over cos squared theta minus 1. And now my advice is, because you're dealing with a fraction there, make them both fractions. Let's give a common denominator, cos squared times cos squared. Let's see what happens here. So we've got 1 minus cos squared theta over cos squared theta, which is exactly where we were here in this step here, or probably here once we had dealt with the fact that that was 1. Okay, so that will then also change to sine squared, and sine squared over cos squared is equal to tan squared. So more than one option. But like I said, I find that not everyone notices this one, and so sometimes we're better off just going the common denominator route and doing it in a method that you would probably try in your test or exam. But it's nice to know that there are options out there. Okay, so Very important that you treat the terms as they should be treated and write all tans as sine over cos, and then you tackle it from there.